Okay, welcome to Accelerated Math, Trig to solve angles in a triangle. Alright, let's see what we got here. We're looking at, we've got to find this angle over here, and we're given two sides to this. And we're going to use, I'm sure you remember this SOHCAHTOA, Old Chief SOHCAHTOA. Alright, and depending on the sides that they give us, if they give us two sides to find an angle, then we're going to use this inverse function. If they give an angle, then we're going to work it the other way. So we're dealing with sine is a function of opposite over hypotenuse. Cosine, and you can see where these acronyms are coming from. Cosine is the adjacent side over the hypotenuse, and tangent function is going to be used when you have the opposite over the adjacent. Now let's go to kind of figure out, well, where is this opposite, adjacent, all this stuff. You got to start with what they call the reference angle. This is the angle that you're asking about or that you've been given, and you're going to find, okay, well, go directly across from it, and that's going to be the opposite. So the first step I'm going to do every time is label opposite, adjacent, and hypotenuse. Now I don't spell them all out, but at least put the O there. The adjacent is going to be the one next to it, and you might say, well, there's two of them. Here's an adjacent, and the other one is an adjacent side as well. But this one is it is adjacent, but it's going to be called the hypotenuse because it is directly across from the right angle. Okay, so the first thing I want to do is label opposite, adjacent, and hypotenuse, and now we have an understanding of what do we have. We've got the opposite and we've got the hypotenuse, so let's look at our list here and which one of these gives us or works with opposite and hypotenuse. Well, sine works with hypotenuse and opposite, cosine works with adjacent and hypotenuse, and tangent work with opposite and adjacent, so we can't use those, so we've got to go with sine. So here's where we're going to go. We're going to find the inverse function of sine of the opposite over hypotenuse, or 7 over 21. Let's take a look at the calculator and see how this works. I said we're going to do the inverse function of sine, so this is working backwards from the sides to find the angle. When you're given an angle, you're going to use the straight up sine function to find a side length. Alright, so sine, or inverse sine, 7 fraction 21, just like they gave it to us. And whoops, let me sneak out of that and delete that. Come out of this, I can close the parentheses, always a good idea. On this particular one I didn't have to, and I get 19.47. Is that one of our things here? Yeah, we've got B is 19. They said, well, what did they say? They didn't really say. I don't know if they were saying to the nearest degree, but that would be B. Okay, let's take a look. Now here's one, again, where we've got, here's our reference angle. So let's start labeling. You remember I said if you've got the right angle symbol, directly across from that is the hypotenuse. You notice the hypotenuse is not given, so when you look at your SOHCAHTOA, well, you know what? Hypotenuse is used here and used there, so those are not in, so we're going to go with the tangent function. But let me just show you the opposite. This is the opposite side, so we've got opposite, and this one left is going to be the adjacent. So I like to label the hypotenuse first, then deal with the opposite, and then the adjacent is the one that's left over. So they didn't give us a hypotenuse length, so we don't have that as an option, so we're going to go with the inverse tangent function of opposite over adjacent, so 29 over 17. This is not too bad, is it? Let me move this over a little bit, and we're going to clear this. We're going to go, now it's bad if you don't have one of these calculators or something with a inverse tangent function. I didn't quite get that second. Inverse tangent, 29 over 17. Get out of that, close that parenthesis, hit enter. 59.62, that would round up to 60. Let's see if 60 is there. It is. It's a 60 degree. Okay. Alright, let's go to the next one. Well, it seems easier than I thought. Alright, here's one. Ooh, I really like this one. It's like going to the buffet. You can choose anything you want. Look what they've given me here. Here's the reference angle, This is the opposite. I said I also like to label that hypotenuse right up front because it's across from that 90-degree symbol or the right angle, and then this leaves adjacent. They give us all three sides, so we can choose our favorite one. SOHCAHTOA. Which one is my favorite one? I think sine's my favorite one, but you know what? We used that a minute ago. We used tangent, so let's use cosine. You could use any one. This is the inverse cosine function, adjacent. That's 55 over the hypotenuse. That's 73. Let's go to our calculator and pull it over just a little bit more. I'm going to clear that. I got second cosine function, 55 over 73. Get out of that. Wow, I didn't. Let's try that one more time. Second cosine function, I've got 55 over 73. Get out of that. Close that. Wow, I am just, what is my problem? Well, don't answer that. Alright, I need to delete one of those 5s. I guess I should look at the screen while I'm doing this. Alright, and enter. I got 41.1. That's going to round down to 41. And there it is. If you did the same function with the tangent or the sine function, tangent with opposite over adjacent, or sine with opposite over hypotenuse, then you would get the same value. Alright, and that's it. That is solving angles in a triangle using trigonometry. Have fun.